Hey folks, today we're going to look at river erosion, and there's 4 different types and it can be a little bit tricky to remember these, so let's just do a really quick video on the 4 types. So if you start by, really don't worry about this being perfect. I haven't got a ruler on me, so I'm just going to draw a box like this and just break it into 4 like so. Okay, and then we're going to start by just writing the names. Okay, so I always put hydraulic action and abrasion first because I just think they fit really nicely when we're talking about erosion, and they're kind of the more powerful ones. Attrition and solution are still, don't get me wrong, still really important, but if there's 2 that I want you to take away and remember, then it's these 2. So the first one, hydraulic action. So this one is the force of the water, okay? Just underline that slightly so it's out of the way. Right, how we're going to do this, we're going to draw kind of like a riverbed and bank, okay? Kind of like that. And then we're going to draw the river water, like so, okay? And basically, this is a very flat river, obviously it's not doing a great deal, but in flood situations it can be super powerful. So a metre squared of water weighs a ton. So you can imagine when this river is flowing really fast, it is really powerful and it is going to cause little cracks to form in the banks, in the bed. So erosion is not just happening laterally, like on the sides where this riverbank is being, cracks are being caused, but it's also happening kind of vertically as well, because this river is going to get deeper, isn't it? And it's going to get deeper because of hydraulic action. Because when these cracks form, eventually air gets in, water gets in, and what happens is the riverbank will give way. Okay, so once you've put a good number of cracks in place, like so, we're going to write the definition. So we're going to put, it is the force of water. You know, I really can't stress how powerful this could be. Think like, a fire station, a fireman's setup, with a really powerful hose, a bit like a jet wash, but bigger. Rivers are incredibly powerful, okay, especially in flood conditions. So it's the force of water. Force of water causes cracks in the riverbed and banks. Okay, and ultimately what that's going to do is it's going to make the river deeper and wider. Okay, right, moving over here. So the next one, the one I think it's a really, really important one, arguably as important, if not more important, than hydraulic action. So again, if we draw our kind of riverbank and the riverbed, so it's the riverbed down here and the riverbank there. Okay, and then again, if we let's put a slightly more active river water in there. Right, on the riverbed, you've got large boulders, particularly in the upper course. Okay, now these are moving and scraping and rolling their way along, and they'll be actually acting a bit like sandpaper and wearing down the riverbed. But not only that, you've got smaller bits of material and sediment that is basically being used again like sandpaper, and it's whacking into the banks of the river, and that is also going to be kind of wearing them away. So it is really this kind of sandpaper effect. So if we write for this one, stones act like sandpaper because they're abrasive, and that's where that word abrasion comes from. Okay, it's an abrasive action. So stones act like sandpaper on the riverbed. and banks. So those two words are, I arguably think, are the most important. But there are two more types of erosion, and I've seen this in the exam before where you have to define them or use them, or a word fill. So don't ignore them. Don't think, oh, I don't need those ones. You do need them all. And they are attrition and solution. Okay, these are the ones that AQA use. So again, just like we did before, if we draw our riverbed and our river banks, for this one, we're not actually going to use it in this one, but for this one's fine. And we're going to draw a slightly more full river on this one. There we go. Now, I really like this one. This is where two pieces of material bash into each other. Okay, so basically just draw some stones kind of whacking into each other like whoop. You can even write the word bang, question, ouch. Okay, so this is where angular material, so edgy material that has kind of sharper or more angular edges in the upper course, ends up being super smooth by like the middle course towards the lower course, and by the lower course it's actually been eroded down to almost nothing. But basically by knocking into each other, they are knocking the edges off each other. They are rounding each other down, just literally by bumping into each other. So that's attrition. So for this one, we need to write stones and sediment. That word just means all kind of river load, river material. Bump into each other. Getting smaller. So it makes them smaller, it breaks them, but it also makes them rounder. Or you could have written there smoother. Okay. So those three of the four. Right, the last one, I'm not actually going to draw a river. I'm going to draw like a glass. Yeah, kind of like this. And you could write water. So this is happening in rivers, but we're going to show you what happens with sugar and water. So basically, solution is where the water naturally dissolves minerals that are in the rock. Okay, and the only way I can ever really explain this to my students in a way that makes sense, or to others, basically, is to draw it. So yeah, so if you imagine sugar cubes, okay, when they go into the water, what happens is they dissolve. You can't see them. They're still there. They still exist as sugar, but you can't see them. So we're going to write chemicals in river water cause minerals in the rock to dissolve. Okay, and it's as simple as that. So there you go. So your 4 types of river erosion, and yeah, I just hope that was helpful.